Okay, mic test check, hello. Okay, so in this video, we will be solving several questions, hopefully all, under a worksheet made by Kuta Software. So this is about partial fraction decomposition. Um, yeah, that's all I'm gonna say. It is important. Uh, this is usually learned in the first term or first semester of whatever engineering that you're taking. So yeah, I already started number one before um, recording, so that's a given. Uh, I just wanted to see if I'm already ready in teaching what I understood. So let's start with number two. By the way, um, well, let's go to uh, partial fraction. Okay. Basically, what I want to say first is basically there are four cases for partial fraction. So I know there are formulas for each, but I don't think it's necessary to memorize them. As long as you know the general steps on what to do in a certain scenario, especially when solving, then I believe you're good to go. So just know that for the first two, factors of q over x, that by the way is the denominator of a rational expression. I think it's at the first page. Nope. Okay. So given a rational expression where p of x is the numerator and q of x is the denominator, basically there are polynomials, we can decompose it into a sum of partial fractions. So from there, basically the denominator is said to be linear. All factors of the denominator are linear. For case 1, none are repeated. For case 2, some are repeated. For cases 3 and 4, all factors of q of x are linear and quadratic at the same time. What does that mean? For example, linear having a degree of polynomial just equal to 1. And another is a quadratic, so there's something like this. So a linear and a quadratic. Okay. When we say some are repeated, regardless if we're talking about case 2 or 4, uh, basically the idea is, for example, oops, are we all good? Okay. Um, let's talk about case 2 first. So we have something like this, right? We have x raised to 3 and x minus 1 raised to 2. So we'll be writing x raised to 3 at the other side, x raised to 2. Basically, the exponent is given a minus 1, so it becomes 2. And then another minus 1, it becomes x. It would just become x. And here, x minus 1 raised to 2, we'll write it. And for the next fraction, it will be, the exponent will be given a minus 1, so it will be just x minus 1, and then raised to 1. So, yeah, that's basically it. And also here, for case 4, if we have a raised to in the denominator, the next fraction will have a minus 1 of it. So 2 minus 1, which would be 1. More on that later. Let's now go to the application. I almost forgot to mention, there are two methods on how to solve for the partial fraction decomposition. Method 1 usually is applicable in simpler problems, so we just plug in x values. Whatever that value is, we know that it would make it's difficult to explain without an example. More on that later. Just remember x value plugin or setup. For method 2, this is usually used for more complex problems. Usually when you cannot use method 1, you immediately proceed to using method 2. So we equate coefficients. Systems of linear equations are involved. So let's go back. Let's start with number 1 officially. So first things first, copy the fraction again. Copy the numerator. For the denominator, if it's in a simplified form, you factor it. Like so. And then for each factor, you write out a separate fraction. So that one's for the factor x plus 4. The other one would be for x plus 5. Now, we need to find the LCD. We need to eliminate the fraction. Sorry. We need to eliminate the denominators in layman's terms. So what's the LCD? Or the common denominator? By the way, we'll be placing in the numerator of the right side of the equation a and b. That's what we ought to look for. And after looking for a and b, we write this same thing, but this time with the constant values of a and b respectively. And that would be the partial fraction decomposition answer. Okay, other side. And then 3x plus 10. These guys eliminate each other. X plus 4. So we're left with this kind of equation. So what's the next step? We can apply method 1, the setting up of an x value. So what do we do? Either I'm thinking we look for b. Actually, any would do, but I'm choosing to look for b, such that a, this entire term basically would be equal to 0. How do you make that happen? If x is equal to negative 5, then this would be 0. 0 times a is 0. So let's do that. Set x is equal to negative 5. So 3 times we use this, we assume that x is negative 5 in this equation. So let's do exactly that. 3 times negative 5 is negative 15 plus 10 negative 5. This one would be 0 immediately, and then b, and then negative 1. So what we're left with is negative 5 is equal to negative b. b is equal to 5. We already know what the b value is. Let's look for the a value. So 3x plus 10 is equal to... How do you, by the way, determine the value of a, even without the value of b? Set x is equal to negative 4 this time. So 3 times negative 4, negative 12, plus 10, that's going to be negative 2. And then a times negative 4 plus 5, that's 1. And then plus b, well, this is going to be 0. So we're left with a is equal to negative 2. That's it. Now that we know what a and b are, we go back to the very first form. So we just copy it, what's given. 3x plus 10 over x plus 4, sorry, x raised to 2 plus 9x plus 20 equals to x plus 4, x plus 5, and then I think one is a over here, the other is b. So this time, what we do is substitute. So a becomes negative 2, b becomes 5. This is the final answer, the partial fraction decomposition. According to the answer key, we are indeed correct. So this kind of question is relatively simple. I've seen more complex questions, definitely. And I have to say it now, I am not confident if I'd be able to discuss the process correctly. Anyways, let's go to number 3. So, same protocol. How many questions do we have for this worksheet? 12. It's been a few minutes already and we're still at number 3. Goodness. Okay, A and then B. Same protocol, LCD, as well as in the other side, on the other side. Okay. We can still use method 1. So set x is equal to 1 so that A becomes 0, this part. And then we can find B. Negative 2 plus 4 plus 14 is equal to B times negative 4. (18) 16. B is equal to negative 4. Set x is equal set s as equal to 5. So 25 negative 50 plus 20 plus 14 is equal to A times 4. 34. Negative 40, negative 16 is equal to 4A. A is equal to negative 4. So from there, just copy paste this entire thing. A and B. So A is negative 4, B is negative 4. You can just say minus 4. So this is the final answer. I think we're missing something. According to the answer key, we are missing something. Can we check? By the way, in order to check if your answer is correct, of course, there has to be a reason why there's an equal sign here. So whatever, if you simplify this, it should equal to this. Let's do exactly that now. Okay, something is wrong. This is definitely not equal to this. according to the answer key, well, there's nothing wrong here. We just needed a minus 2. I'm not sure about this question. Maybe it has something to do with this. If you factor 2 in the numerator terms. I really am not sure why there's a negative 2. But I suspect um, because we have, because the numerator can be factored, there's a common, well, 2 is what's common in all of the terms. That's exactly the number that we put here. That's what I think. Although it's not official, we still, maybe something, once we answered another problem that's similar to the idea, then perhaps we could reinforce that observation. Uh, we could recognize a higher level of credibility in that observation. Number 4. X. Okay, we have A and B. So LCD, A times X minus, quantity X minus 5, and then BX. Set X equal to 0 to find A. Now to find to find B, set x is equal to 5. So 50 minus 45 minus 10 is equal to B times 5. Negative 5 is equal to B times 5. B is equal to negative 1. Now, we have 2 over x plus, well, minus 1 over x minus 5 is equal to 2x raised to 2. Well, we just copied the problem itself. Let's see if this is correct. It is, but we lack a 2 plus, according to the answer key. Okay, so where did that 2 plus come from? I don't know. Let's go to number 5. If we use method 1, I don't think we would find anything. I don't think it would work. Let's try method 2. Because think about it. If you let x equal to negative 3, that would also go for the one here. So both a and b, the entire right part of the equation would be 0. So there's no point, right? You can't really find a or b anymore. So method 2, how does this work again? Okay. So we further simplify the equation, particularly the right side. So ax plus 3a plus bx plus 3b. So these are like terms, so factor the x from them. And then we just have constants in the end. So from the exact term, equate coefficients. So what's the coefficient of our x raised to 1? In the left side, it's negative 7. So whatever is here, write it here. So a plus b, and then place the coefficient. So yeah, they should match. For the constants, 3a and 3b, copy. And then the coefficient of the constant, well, it's exactly the same number, so negative 15. This is where it looks, this is where what we just wrote would look similar to simultaneous equations. We have a problem though. I think I've made a mistake in the first place. This is supposed to be, well, it's not necessarily wrong to spread out the factored form of the denominator, but we know that there's a raised to 2. In that case, we write x plus 3 raised to 2 and then x plus 3. This one is 2 minus 1. That's going to be raised to 1. Sorry about that. This is actually a dead end. Because if you multiply both sides by 3, well, there's no point because even if you minus, both a and b will be 0. So this is an absolute dead end. Sorry about that. So we have a and then b times x plus 3. A plus bx plus 3b. We could try method 1, but let's try method 2 just for this problem. Besides, I've already simplified it. I mean, the equation. So b is equal to negative 7. So the coefficient of the x raised to 1 is negative 7. In the right side, whatever is associated with x, such that it's multiplied. So b is negative 7. A plus 3b is equal to negative 15. Simultaneous equations. So we know that b is negative 7. 3b is negative 21. 21 minus 15, that's going to be 6. So b is equal to negative 7, a is equal to 6. Let's see if, so this is method 2, right? Let's see if method 1 yields the same answers. Just to be flexible. Method 1 is about what again? X. Okay, setting up x values. So set x is equal to, so coming from here, so we want to eliminate b to find a. I think that's the only way that we're seeing right now. So negative 7 times negative 3, 21 minus 15, that's 6. In the right side, a, that's it. This entire term is 0 immediately. So a is 6. Exactly the same value that we found using method 2. Let's try to find b this time. So there is no way to find b through method 1 because a has no x multiplied to it in any way. So I think we fared better doing method 2 instead because we could just go, we were able to find 2 of what we ought to look for. For method 1, after looking for a, we use method 2 to look for b. But we don't have to anymore because we already did method 2. So what do we do now? So we just copy the problem. Negative 7x minus 15 over x raised to 2 plus 6x plus 9 is equal to a over x plus 3 raised to 2. A is 6. And then the other one, x plus 3 raised to 1, b is equal to negative 7. So write it like that. Okay, let's see if the answer key matches my answer. If my answer matches the answer key. Yes, it does. Okay, good. I'll minimize this. It was good that we also used method 1, but it wouldn't be so useful in the concerning situation. Okay, how do we factor this? So, even before starting, I'm already seeing difficulties in factoring the denominator. How, I think, let's try, do you think completing the square is possible here? Okay, I think we're getting somewhere. Just have to be creative. We factor out x minus 1. This is a lot of work for just one problem. We haven't even started with the main part yet. Can we skip this question for now? Okay, this is more like it. So we have an x, we have an x plus 1, the other is an x minus 1. We have an a, b, and a c. I think this is case 2. Okay, let's try method 1. Set x is equal to equal to 1. So we'll be eliminating a and b, c would remain. So it would go like this. Negative 6 times 1 is still negative 6. Plus 3 times 1 is still 3. Plus 5. And then a and b, these guys are 0. So we have c times 1 times x plus 1, that's 1 plus 1, that's 2. 8 minus 6 is 2. And then we have 2c. C is equal to 1. Next. I think it's best we use method 2 this time because there is no other way. Equate coefficients. Now with simplify, we have to simplify the equation. Just copy the left side and then x raised to 2 minus 1. Ax raised to 2 minus a plus b times x raised to 2 minus x plus c times x raised to 2 plus x. So bring together terms that have the same the same variable and exponent. Like terms, basically. Okay. And then the other side, just copy. Now, let's start equating. So, for x raised to 2, we have a plus b plus c equal to the coefficient of the one with x raised to 2 That's going to be negative 6. For this, we have negative b plus c. The coefficient of x is 3, according to the left side. And then we have negative a is equal to positive 5. Continue. A, it is implied that a is equal to negative 5. That's a given. We can find what b is because we already knew c earlier. Negative b plus 1 is equal to 3. Negative b is equal to 2. b is equal to negative 2. Let's see if the values are correct in one way. Let's see. Negative 5 plus negative 2 plus 1 is equal to negative 6. That is true. Negative 7 plus 1 is negative 6. That's good to know. So, what do we do then with the three variables? Again, just copy the given. And then all of this. Actually, I'm not gonna copy paste. I also need to practice how to write it manually. So A is negative 5, B is negative 2, or write it like this. And then C is positive 1. Okay. This is the final answer. Let's see if it's correct. Number 7. Negative 5 over x minus 2 over x plus 1 plus 1 over x minus 1. Okay, nice. It's correct according to the answer key. Number 7 is answerable on my end. Next, 20x plus 9, 5x, 5x, and then plus 2, 10, 20. Okay, we can just write it like this. Next, the other side, 5x plus 2 raised to 2, and then the other one would be 5x plus 2 as well, but this time it's going to be minus 1 in the exponent, so that's going to be raised to 1. We have A and then B. Multiply both sides by okay. 20x plus 9 is equal to A plus B times 5x plus 2. Method 1, set x equal to 0 so that this term becomes 0 and we can look for A. So 20 times 0 is 0, 9, and then we have A. 9 is equal to A. How about B? I think we can only use method number 2 to find B. So that means we have to simplify the equation. 20x plus 9 is equal to A plus 5bx plus 2b. X times 5b plus A plus 2b. Start equating. So for 5b, the coefficient for x is 20. For A plus 2b, the constant, so coefficient is 9. b is equal to 4 if you simplify this equation. And just to verify if our a and b are correct, let's see if it matches the equation here. So a is 9, right? And then 2b is 8. Okay, something's wrong. Something is wrong. Yeah, I can see my mistake. So earlier, I guess mental math isn't gonna help you. There's still human error, a tendency for human error. So after setting x is equal to 0, so we have 9 on the other side, we have a. This one is not entirely 0. It's actually, so 5x is 0, right? We still have positive 2, so it's 2b. I guess we don't use method 1 for this kind of question. We immediately resort to method 2, which is this. So far, B is correct. What we did earlier, the solution that I just deleted, had nothing to do with this, so nothing's wrong here. What we can do is, now that we know what the V value is, which is equal to 4, we look for A. So A plus 2 times 4 equal to 9, according to this equation. So A is equal to 1. That's it. One over, and then B is 4. Number 8. Okay, so this is just one major concern. I am not sure if it is okay to interchange, because according to the answer key, the answer is like this. So yeah, just kidding. Actually, the answer is correct. I was overthinking. Yeah, the answer is correct. But if ever, it still begs a question. What if instead it goes like this, 4 and 1? So do you think the answer is still the same? I'll leave that to you, because I have no idea either. What's the answer for that question? Just try to play it safe. A always comes before B. And whatever is the higher degree, which is 2, that's what you place with the first variable, which is A. And then the one with the lower exponent, which is basically 2 minus 1, that's where you place the next letter, which is B. And so on and so forth. For example, we start with raised to 3. This is raised to 3. This is raised to 2. And if we have a C, then that's going to be a raised to 1. That's exactly what I intend to mean. Okay. Number 9. Okay, so it appears to be that for number 9, we already have the denominator in factored form. So I think that's a good thing. We don't have to uh, execute an additional step. Okay, so for the first fraction, let's go with x plus 1. Sorry about that. X raised to 2 plus 3, and then we place a raised to 2. The next one will just be a raised to 1. And then A, B, C. Let me just consult my other. So this is case, wait, case 4 is case 3. What I just find strange is recently we've been always using A, B, and C for the numerators. We haven't used an AX plus B yet, or a CX plus D. That's what I was. That's what I'm concerned about right now. Or maybe there's no need yet, so far, in what we've been answering. I guess not. Maybe what I'm thinking is, for example, if we have basically 3 terms in a quadratic, so that should call for an AX plus B, not just an A. If it's an A, then it should look like this, what you're seeing right now for this. Can we reposition these two? It doesn't look right seeing the order of terms in improper order. It has to be in descending order always. A, and then x raised to 2 plus 3 raised to 2 plus B x plus 1 plus C x plus 1 and then x raised to 2 plus 3. Okay. So looking at I think we can use method 1. Set x is equal to negative 1. So we will be eliminating this and this. Well, no. We're actually not going to. Again, we have a plus 3 here, so that's gonna keep this term from being 0, as well as the plus 1 here. What do we do? Let's not use method 1. Let's go to method 2 immediately. Again, for method 2, we use it for more complex scenarios. One of them is this. So simplify the equation further. plus 6x raised to 2 plus 9 plus bx plus b plus cx plus c, sorry, x raised to 3 plus 3x plus x raised to 2 plus 3. Okay, my stylus stopped working for a few seconds. I don't know why. Are we all good? 3, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Attendance check is finished. We group like terms. Actually, the work has already been done. We just have to factor. X raised to 2, and then we have 6a plus c. Other side, 3c plus b plus 9a plus b plus 3c. Next. Okay, I think that's already good. Spare me the writing. Time to equate coefficients. So, by the way, just for formality, x raised to 4 times a, and then x raised to 3 times c. So a, for the x raised to 4, the coefficient is negative 4, according to the left side. C, for the x raised to 3, the coefficient is negative 2. At this point, we're already given the values of two variables already. I think that's a good thing. 6a plus c, for the x raised to 2, corresponding coefficient is negative 26. 3c plus b, corresponding is negative 8. How about 9a plus b plus 3c? That's equal to negative 44. Let's confirm if a and c are correct using this equation. So 6 times negative 4, that's negative 24. And then minus 2, that's negative 26. Okay, so we're sure that a and c are correct. Given c, let's look for b. 3 times negative 2 plus b is equal to negative 8. b is equal to negative 2. Okay, so we already know what a, b, and c are. Let's confirm, just to be extra sure, using the last equation. So 9 times negative 4, negative 36, plus b, that's going to be minus 2. And then minus 6 is equal to negative 44. 8. Yes, that is correct. Okay, so all in all, okay, this is going to be a challenge. We write this entire thing. Hell, it's not going to fit. I need more space. I think the next page would do. Okay, is equal to, again, x plus 1 is a, and then x raised to 2 plus 3. Highest degree is 2. That will be for B. And then the lowest degree, that will be for C. A is what? Negative 4. B is negative 2. C is also negative 2. So this is what number again? Number 9. Let's see if the answer is correct. Negative 4, x plus 1, negative 2, x raised to 2 plus 3. Okay, so they're correct. The answer key did, well, it was written the other way around, what you're seeing right now. But I think it doesn't matter, like in terms of order. It's just like saying 1, negative 1, negative 2 is negative 2, negative 1. Nothing changes. It's still the same thing, despite the difference in order. Let's answer number 10. Okay. So we have an x, we have a raised to 3, a raised to 2, and a raised to 1. So we have 4 variables to look for, a, b, c, and d. LCD, x times quantity x minus 5 raised to 3. Other side, so what we're left with is negative 2x plus 3 plus 30x raised to 2 minus 199x plus 375 is equal to a times x minus 5 raised to 3 plus b times, well, just bx, and then c x times x minus 5, and then plus d x times the quantity x minus 5 raised to 2. Is there a way to use method 1? Even if it's possible, I don't think I'd like to use it. There's too many variables to set a value for x for elimination. But is it possible? I think it is. So that you could look for b. If you set x as 5, let's do exactly that. Set x is equal to 5. So let's do that. 2 times 25 times 5, 125 plus 36 times 25 minus 199 times 5 plus 375 is equal to a. Well, a would be, this would be 0, because 5 minus 5 is 0, 0 raised to 3 is 0, 0 times a is 0. Same goes for c and d over here. So we're left with bx, such that x is 5. Okay, we'll be using a calculator. This is too big for us to mentally compute. What is this? 107. Imagine, I've been speaking since, I guess, for over an hour, and you realize that it did not record. That's a different level of misery. Okay, 30 is equal to b times 5. B is equal to 6. We know what b is already. I don't think you can still use method 1 to find the other variables. This is where we resort to using method 2. So, coming from here again, we simplify the right side. So, A is x raised to 3 minus 10x raised to 2 plus 25x minus 5x raised to 2 plus 50x 35, 50, 75, 100, 125. Let's just simplify this entire thing first. Negative 15 plus 75x minus 125. This is annoying. You can never do this in physical paper, which is very problematic in my opinion. Let me just copy the rest. Wow, it's already 1 a.m. I have to wake up at 5. This is gonna be problematic. It's already 1 a.m. I think I'll have to end the video after this question. I'll continue. I guess I'll make a part 2 to answer the remaining questions and see if I could still answer number 3 where we've been stuck in since earlier. So we only have one constant. That's 125a. Okay, from here we can now equate the coefficients. So a plus d is equal to negative 2. Negative 15a plus c minus 10d is equal to 36. 75a plus b minus 5c plus 25d is equal to negative 199, and negative 125a is equal to 375. We can use, I guess, the space here. So 375 divided by 125, what's that? 3? I think it's 3, yeah. So a is equal to negative 3. What did we find earlier? B, right? So, okay, there's no way to find B as of now. We can find D using A. So D is equal to 1. Negative 3 transpose to the right side, 3 minus 2 is 1. A, C, D. Let's look for C. Negative 15 times A plus C minus 10 is equal to 36. C is equal to, okay, so 45, 35, the right side, 1. C is equal to 1. A, B, C, D. Okay, I think we found everything already. Other side, let's copy this. Okay, issue is it won't. I guess we're taking this to the next page. What is this? One question per page? That's crazy. Okay, so A is negative 3, B is 6, C is 1, D is also 1. Let's see if the answer is correct. Number 10. Negative 3 over x, 1 over x minus 5 raised to 2, 6. Alright. The order isn't the same, but they're exactly the same fractions. So technically it's correct. That's it for this video. Thanks for watching. I'll make a part 2 for the remaining ones.